Here we have a city math problem. Okay, let's go to the question. In the figure above, the area of square ABCD is 36 and M is the midpoint of the line segment AD. What is the area of triangle ABE? Okay, using the given information, we have to get the area of this triangle ABE over here. Okay, here we have the area of the square ABCD. To get the length of each side of the square, we have to take square root of the given area. When I find square root of 36, that is 6. So that is the length of each side of this square is 6. Here we have 6 and the length of this side AD is also 6. Since M is the midpoint of this line segment AD, so this M will divide the length of AD into 2 equal parts. That is, it will divide 6 into 2 equal parts. Then the length of AM over here is 3 and MD is also 3. Since it is a square, at each vertex will have a right angle. So here we'll have a right angle. Okay, now we can consider the right triangle ABM over here. In this right triangle, so this AM is the base and this AB is the height. So using the formula base times height divided by 2, we can get the area of this right triangle ABM. Okay, once we get the area of this right triangle ABM, we can try to get the area of this smaller triangle AEM. Then we can subtract the area of this smaller triangle AEM from this right triangle ABM to get the area of the required triangle ABE. Now we can consider the angle measure over here and angle measure over here. These two angle measures are equal because they are vertically opposite angles. And also in a square, opposite sides are parallel and equal in length. So the side AD and the side BC are parallel. Then we can consider this AC as a transversal. Then the angle measure over here and angle measure over here are alternate interior angles and they are equal in measure. Now the two interior angles of this triangle AEM are equal to the two interior angles of this triangle CEB. So by angle similarity postulate, the two triangles are similar. Okay, now let me write the vertices in order. Let me consider the vertices of this triangle first. So let me consider vertex A over here. The corresponding vertex in the other triangle is C. Because at the vertices A and C, we have equal interior angle measure. Okay, now let me write over here, that is vertex C. Now let me consider the vertex E in this triangle. So E, and the same vertex we have for this triangle as well, that is E. And the third vertex for this triangle is M, and the third vertex for this triangle is B. Okay, let me write it. So these two triangles are similar by angle similarity postulate. Okay, in this triangle AEM, we have the length for the side AM, that is 3. So let me consider the side AM in the first triangle. Let me write over here. What is the corresponding side in this triangle? For that, we have to consider the letters at the same position. So that is CB. CB is the corresponding side for AM. So let me write CB over here. Now I got the ratio of the corresponding sides of these two similar triangles. Okay, here we have the length of AM, that is 3. And also we have the length of CB, that is 6. Okay, so here 3 goes into 3 one times and 3 goes into 6 two times. So here we get 1 over 2. So in these two similar triangles, I got the ratio of the corresponding sides, that is 1 over 2. Okay, now let me draw a vertical line in the given figure through the point E over here. Let me draw a vertical line over here. So it's a vertical line. Since it's a vertical line, it will intersect the side BC of the square at right angle, and also here also it will intersect at right angle over here. And let me take the point F over here and G over here. So this EF represents the height of this triangle AEM, and this EG represents the height of this triangle CEB over here. Okay, in whatever ratio we have the corresponding sides of these two similar triangles, in the same ratio we'll have the heights of these two similar triangles. Okay, we know that height of the first triangle is given by the line segment EF, and the height of this triangle, second triangle, is given by the line segment EG. So EF over EG. So this is the ratio of the heights of the two similar triangles. The same ratio, whatever ratio we get for the corresponding sides, the same ratio we have for this one as well. That is EF over EG is equal to 1 over 2. Now from the terms of the ratio, if I want to get the length of this line segment EF and the length of the line segment EG, I have to multiply the terms of the ratio here by the same non-zero number, say x. When I multiply this 1 by x, I am getting just x. When I multiply this 2 by x, I am getting 2x. So the length of this EF is just x. The length of this EG is 2x. Okay, here we can mark that EF over here as x, and here we have 2x. What is the length of this GF over here? For that we have to add this x and 2x, and I'm getting 3x. Actually, the length of this GF is 6. That is whatever length we have for this vertical line segment AB, the same length we have for this GF as well, that is 6. So this 6 and 3x, both of them represent the same stuff, that is the length of the vertical line segment over here, GF. So then we can equate 3x and 6. Let me divide both sides of this equation by 3. Then this 3 will cancel out. Then x equals to 6 divided by 3 is 2. Okay, here we got that x equals to 2. So here we can plug in x equals to 2. When I plug in x equals to 2, here I'm getting 4. Okay, here the length of EG is 4. And the length of EF is 2. Okay, for this right triangle AEM over here, we have the base 3 and height 2. Now we can get the area of this triangle AEM. Already we have the base and height for the right triangle ABM. As I said earlier, we have to subtract the area of this triangle from the area of this right triangle ABM to get the area of the required triangle ABE. Okay, now let me write the required stuff over here. That is the area of the required triangle. That is triangle ABE equals to area of the right triangle ABM. Let me write over here. Negative area of triangle AEM. Okay, here we can use the formula base times height divided by 2 to get the area of these two triangles. Okay, first let me get the area of this triangle, right triangle ABM. So for the right triangle ABM over here, the base is 3 and the height is 6. That is, we have to plug in this 3 for base over here and this 6 for height over here. Then I am getting 3 times 6 divided by 2. Negative. Now to get the area of the triangle AEM, we have to consider the base 3 and the height 2. Then I'm getting 3 times 2 divided by 2. Okay, here 2 goes into 2 1 times, 2 goes into 6 3 times. Here this 2 will cancel out. Here 3 times 3 is 9. Negative. Here we just have 3. 9 negative 3 is 6. Okay, here I got the area of the triangle ABE. It is 6 square units.